Every year, Florida homeowners face a miserable choice after a major storm: pay a couple $1,000s to patch their pool cage, or write a check for $25,000 to tear it down and start over. Guessing which option you need based purely on how the metal looks from the patio is a financial trap. This split screen shows exactly why. A cage that looks perfectly fine can have the exact same structural failures as one that's already in the pool. To actually know what you're dealing with, stop looking at the enclosure as a single object. It is a combination of 3 distinct systems: the mesh screen, the aluminum frame, and the base anchors. Each degrades at a completely different rate. Misdiagnosing which system has failed means you will either pour cash into a dead structure that needs to come down anyway, or you will overpay to demolish a frame that only needed a routine tune-up. The engineering logic leads to 3 distinct paths. A simple rescreen replaces the mesh for $1,200 to $4,500. Structural repair swaps corroded hardware for $600 to $2,500. Full replacement, rebuilding to current wind codes, costs $6,000 to $30,000. Finding where your enclosure sits on this chart requires an objective look at those 3 specific structural axes. It does not rely on neighborly advice or a contractor's quick guess. The first axis is the mesh. Standard fiberglass typically lasts 7 to 10 years in the Florida sun. By contrast, heavy vinyl-coated polyester tests out to 21 years of life and over 1,300 pounds of breaking strength, doubling your maintenance interval. When you see sagging panels, chalky textures, or the rubber spline pulling out, the material is simply aging out. If the metal beneath it is straight and tight, you are looking at a standard rescreen. Upgrading to that premium 20-year mesh makes financial sense, but only under one specific condition. The aluminum frame holding it up has to be capable of surviving for another 2 decades. That brings us to the second axis, the aluminum itself. On the left, we see cosmetic oxidation. Faded paint looks terrible, but doesn't reduce structural capacity. The right side shows actual failure. Coastal salt air causes chloride pitting, eating away the metal. Pool cages are built from extrusions with walls at least 40 thousandths of an inch thick. Once those primary members bend, twist, or pit deeply, they lose their engineered capacity to resist 150-mile-per-hour winds. Slapping a fresh coat of paint over deeply pitted or twisted aluminum is throwing good money after bad. The frame will collapse the next time a major storm hits the coast. The third and most critical axis is the hardware. When you drive a carbon steel screw into an aluminum frame in a humid, salty environment, you create a tiny battery. The chemical reaction literally dissolves the aluminum around the fastener. This is the textbook symptom. The red arrow points to bleeding rust stains spreading across the concrete from the base plates. Those base plates are the terminus of the entire structure's load path. When galvanic corrosion eats through those anchor points, the enclosure physically detaches from the foundation. If the bottom of the cage is no longer secured to the earth, the thickness of your upper beams and the quality of your screen mesh do not matter. The structure has failed. Engineering realities are backed by strict laws. This graphic shows the impact of the 2023 Florida Building Code update. Vertical wind pressure requirements on solid surfaces jumped by 20 to 27%, meaning older cages are now legally under-designed. Attempting to repair a severely damaged older cage triggers these legal thresholds. Florida statutes and FEMA rules mandate that if a structure sustains substantial damage, it must be brought entirely up to current code. You are legally barred from just patching it. Then there is the slab veto. Base plates rely entirely on the concrete below them. If your footer is cracked or failing, you cannot drill new anchors into it. The foundation must be fixed first. Applying for a permit to do major structural work on an obsolete frame often exposes these code deficiencies. The local building department will reject the repair and force a total teardown. The final decision comes down to a strict financial threshold. Once the quotes for patching hardware, replacing panels, and repainting hit 40 to 50% of the cost of a brand new cage, the math turns against you. Here is how you apply it. If your frame is straight, the joints are clean, and the anchors are tight, but the mesh is sagging and the paint is chalky, you confidently pay for a rescreen. If the frame meets modern wind codes but has isolated bleeding rust at a few base plates, you schedule a targeted structural repair to upgrade to stainless steel anchors. But if the primary members are pitted, the anchors have dissolved the concrete, or the local building code considers the structure substantially damaged, you must replace the entire cage. Spending half the price of a new build to patch an aging, legally obsolete asset guarantees you will be paying for a full replacement in a few short years anyway. Navigating this requires a builder who uses engineering to diagnose the problem, rather than just selling you what they have in the truck. That is where Screen Factory Florida steps in. They eliminate future points of failure from the start. They build with oversized 8 to 10-inch beams, marine-grade 316L stainless steel hardware to stop galvanic corrosion, and premium high-strength polyester mesh. They hold an A+ rating with the Better Business Bureau and a 4.8 customer score because they manage the entire process, including the complex local permitting that traps so many homeowners. Click the link below this video to schedule a free, no-obligation engineering measurement and consultation. Protecting your home's value in a 150-mile-per-hour wind zone means refusing to guess. Get the math right and get the structure built right the first time.